everybody. So what I want to talk about in this video is some other types of graphs out there. So in my video series, I've talked about stem and leaf plots, histograms, dot plots, box and whisker plots. I just want to talk about one of the other types of graphs out there that you could run into that are still super important to know how to read them and kind of the important features of them. So the graph I'm going to focus on today is called an Ogive, which is just a cumulative relative frequency plot. Okay, what it's going to do is it's going to take a lot of the information that you would typically see, say, in a histogram, but it kind of converts things over to percentages, but also talks about cumulative percentages. Okay, so here's what I mean. And I just made a very, very rough example here. It's not meant to be like, oh, wow, this is so perfect. It's just something to try and drive my point home. So what I have here is my cumulative relative frequency plot. I just did a made up data on the number of detentions a student has had. So like if I went through my school and said, hey, how many detentions have you had? And I write them down. And I collect that whole data set. What this is it shows kind of percentages of the kids that answered certain things. So like 0, these are kids that would have 0 detentions. If you look at the cumulative relative frequency plot, we're at 30% at 0. What that means is 30% of my data set had 0 detentions, okay? Had 0 detentions. Here's where things get different though. As you move further along, it is not an accurate representation of exactly that data point. So I believe this is 0, 1, 2, 3. So this point right here, this is 3 total detentions, and we're at 80%. So it would be incorrect to say that 80% of my data has had 3 detentions. Because think about it. I just said 30% of my entire data set has 0, and 80% has had 3 total. That's not true, because then I'm now over 100% of my data is not representative. So here's where the cumulative relative frequency plot comes in. When we look at 80% of our data at 3, what this means is 80% of my data set has had 3 or less detentions. So if I counted up how many total data points I have at 0 detentions, 1, 2, 3, and I added all of them up, it would account for 80% of my data. If I want to know how much percent of my data actually had 3, I just need to look and see what is the difference between the previous one and this one. So at 2, I was at 40. And at 3, I now jump up to 80%. So I went from 40% of my data set had 2 to now 80%, or that's 2 on down, to 80% have had 3 on down. So doing a simple math there of 80 minus 40, I know 40% of my students have had 3 detentions, okay? But if you look at it just at that point alone, that means 80% have had 3 on down. One more way to say that is like this point right here, 2 is at 40. So that means 40% of my students, 40% of my data set has had 2 or less detentions. So that makes up all the people who said I've had 0. That makes up all the people that have said I've had 1. That makes up all the people that have had 2. So 40% of my entire data set have had 2 or less. Okay, so that's kind of how you read an individual point there. So it represents that data point on down, but it is possible doing some basic math to see the difference between the previous point to that point to figure out how much percent of my data is at that point, okay? So other things to focus on with Ogives, or cumulative relative frequency plots, is you kind of want to look at the slopes here, okay? You want to look at the slopes. The slopes are going to represent where is a lot of data and where is none of the data. Because remember, it's a cumulative. It's adding up all the data points before it. So we have a few points where it's completely flat, and then we have a steep point here. So at 0, I have 30% of my data accounted for. When I move to 1 detention, I'm still at 30% of my data. So when you're flat, what that means is I didn't get any more data points. You know, when I'm counting up, all right, raise your hand if you've had 0 detentions. 30% of the hands in the room go up, okay? And I'll say, all right, keep your hands up if you've had 0 or 1. Guess what? The same amount of hands are still in the air. Nothing has changed. That means there was no one additionally that raised your hand to say, I have had only one detention, okay? So when you see flat, that means the absence of data. There is nothing that is accumulating or adding to our data set there. On the flip hand, whenever you see increases, so we went flat, increase, big increase, flat, increase, increase, flat, increase. Anytime you see an increase, that means you're adding more data to the set. Now let's look at our extreme values. When you see steep increases, that means there is a lot of data there. Okay, so huge jumps from one point to the next on an Ogive, cumulative relative frequency plot, that represents a ton of data. So what we have here is when we went from 2 to 3, we already did this calculation order. That's a 40% jump. I went from 40 to 80. So 40% of my data is at the 3, the number of detentions, okay? So huge increases on the slope there represents a lot of data. Flat represents no data, okay? And you can even go through and kind of do the math here if you so wanted to and be like, hey, we're at 30 here, we're still at 30, this is 40, this is 80, 80. I think I made this up to be 85, 90, 90, and 100. So just doing some simple math, you can really figure out how much data is at every single point. You could figure out, hey, 30% of my data was at the 0. If you look at 1, we didn't increase anything, so we're still at 30. And then to get to 2, we went up from 30 to 40, so we had a 10% increase. And then 40 to 80, that's a 40 increase, so on and so forth. There's a 0 there. Then we had a 5 and a 5, then a 0, and then 10. If you add all these up, I guarantee you're going to add up to 100%. So all I'm doing is just taking the percentage and subtracting from the previous percentage. So I know 30% of my data here, nothing. 10%, 40%, nothing. 5, 5, 0, and then 10. So you can mess around, do basic stuff like that. Last thing I want to talk about with an Ogive, though, is finding a specific point. So let's say I want to know, all right, I want to know where where the bottom 30% of my data is, the bottom 30%. Well, since we started with a percentage, let's start there and then just see where our graph is. If you just go straight out, guess what? It's right there. So the bottom 30% is just 0 detentions on down. If I want to know who are my worst kids, my ones that have the most amount of tardies, I could say, all right, I want to know like my top 15%. My top 15% would be everyone from 85 on up, because that's 15%. We'll go on out from that 85 and you'll find, oh my goodness, it's this point right here, which was 5 tardies. So people that had 5 or more tardies, they make up the top 15%, okay? So that is kind of how you're going to go through and figure out these Ogives, cumulative frequency plot. Lots of different questions that can be asked about them, but that is a basic interpretation.